Yeah, Bismillahirrahmanirrahim. Assalamualaikum. Okay, today we are looking for the counting principle. Basically, for the counting principle, you learn to count for specific domain that can be determined according to the problem. Okay, and then it is depending on the mathematical theory of counting being used. Okay, this one is mainly encompasses fundamental counting rule, the permutation rule, and the combination rule. We are learning the permutation. Later we are counting and permutation. Okay, for the counting, the order is not important. Okay, the order is not important. Okay, not important. Okay, but for the permutation, the order is important. Later we see this one. What is permutation? What is counting? Okay, basic counting principle. Counting problem are being categorized. For example, how many different eight-letter passwords are there? How many possible ways to pick 11 soccer players out of 20 player team? Uh, Most of these are basic for the computing probabilities of discrete event. For example, what is the probability of winning of the lottery? This one is 50%, 50-50. Right? Basically, based on the coin toss. Yeah, for the basic counting principle, you need to learn. First is sum rule. Second is a product rule. Thirdly is a permutation, and lastly is a combination. Okay. Okay, for the basic counting principle, the sum rule is the task that can be done at the same time. For example, you have two parallel tasks. Okay, you plus the n1 plus n2. And then, for example, the department will award a free computer either to a computer science student or the computer science professor. So, how many choices that you have? 530 plus 15. You have 455 choices. Yeah, so far, do you have any question? Ada soalan ke setakat ni? Okay, basically for the counting, referred to the combination and permutation. Is generally you are counting the maths on the test. In some cases, you also count the possibilities by enumerating them separately. Okay, this one is a generalized sum rule. If you have the task T1, T2, until Tm, that can be done in N1, N2, N3, and so on. Okay, respectively, and no two of these tasks can be done at the same time because this one is not a parallel task. Therefore, there are N1, N2, N3 until Nm ways to do the one of these tasks. Okay, and then we have the product rule, and then we have the generalized product rule. For the product rule, we have broken down into the two successive tasks because this one we are counting, and then if there are n1 ways to do the first task and n2 ways to do the second task, after the first task has been done, then n1 and two ways to do the procedures. Okay, for the generalized rule, we have the procedure consisting of sequential tasks. Sequential mean that it is in order. Okay, and then for the basic counting principle, okay, for the question, how many different license plate there contain exactly three English letters. Okay, for the solution, we have 26 possibilities to pick from the first until 26, because A, if you count A to Z, is equivalent to 26. Okay. Okay, and then there are 26 English play contain like three English three, 1 to 3, and then you multiply 26, multiply by 26, multiply by 26. Okay, boleh? You okay? Ami okay ke Ami? Okay, yang ni it is possibilities of okay, you want to calculate because of we have three contain exactly three English letter. We have 26. Okay, multiply by 26, multiply by 26. So you have 17,576 possibilities. Okay, and then for the sum and the product rule, can also be rephrased by a set of theory. You have learned the theory set. You can have the disjoint and disjoint set, and also a finite set. Okay, for the disjoint, you use the union A1 union A2 until AM, and then for the product is finite. Finite, which means that you can count. You can count, and then you have A1 multiplied by A2 multiplied by A3, and so on. Okay, and then okay, for the basic counting principle, for the product rule, if you have the broken down into successive tasks, if they in one ways to do the first task, and then in two ways to do the second task after the first task been done, then they are in one multiple by in two ways to do the procedures, like the lesson plate, okay, like this one. Okay, and then for example, picking C, then person A and then person E leads to the same group of the first picking E, then C, then A lah. However, these cases are counted separately in the above equation. So we introduce the permutation and combination. Okay, okay. This is the question: how many different set of three people can we pick from a group of six? We have six group: one, two, three, four, five, six, and then every group has have six people, six people, six, 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 six. Okay, there are six choices of first person, five for the second one, and four for the third one. Okay, so if you want to count the possibilities, you multiply six, multiply by five, multiply by four is 120 ways. This is not the correct result. For example, picking person C, then person A. Okay, we have person in A and person in B and person in C. A, we have person B, C, A. Okay, picking the person in C and then a person in A and then person in E lead to same group as first picking E, then C, then A. We have so many possibility. However, these cases are counted separately. Okay, in order to have the possibility counted, we introduce to you permutation and combination. Okay, for the permutation order is important. Please bear in mind for the combination order is not so important. So how many set of two people can we pick from a group of three? We can have the distinct. N is for the distinct option, C for the combination, and R is the element. So uh, the formula is factorial n. This one exclamation mark is factorial n. Divide by n minus r factorial and r factorial. So we have 3 factorial. Okay, is 3 multiplied by 2 multiplied by 1. This one is 1. 1 factorial is equivalent to 3 lah. So here, if you counted as separately, you can find A, C, and C, A. This order is not important for combination, but for the permutation is important. Order is important arrangement, and then an order arrangement of R element of the set. Okay, this one if you use a set, it's called R permutation. Okay, for example, let S 1 to 3, the arrangement of a 3, 1, 2 permutation of S, and the arrangement of 3, 2 is a 2 permutation of S. Okay, the number of R permutation, because we use the R permutation, is basically on the set. This one is on the set cases. Okay, denoted by P, N, and R. N is the distinct option, and R is the element. Okay. We can calculate P and R with the product rule, P and R and n minus 1 multiplied by n minus 2 and so on. Okay, for example, permutation and combination, this one is the 8 and 3, 8 and 3, and then you have 8 factorial, 3 times, 8 multiplied by 7 multiplied by 6 is 336. Okay, this one is divide is equivalent to 8 multiplied by 7 multiplied by 6 multiplied by 5 until 1 divide by 4 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. The formula is 8 factorial is divided by 8 minus r. Okay, minus r is 3 factorial is equivalent to here. Okay, 5. We have 5 here. We have 8 here. Boleh? Nilai tadi okey ke? Ha. Jadi, knowing we can return our initial question, how many different of set of 3 people can we pick from a group of 6? So, let S be Ali, Chris, and Munandi. Choose 2 members to hold the post presidential and vice president of society. How many ways of performing this selection? A. Ali, C. Chris. You can have okay both lah. But order is important for permutation. So A then Chris is not the same for the Chris and Ali. So here also same Ali and Munandi, Munandi and Ali. Okay, you can have either president or vice president. Okay, and then for the permutation you have N. Okay, and PR. N is 3. Okay, and then 3 minus 2 is equivalent to 6. So for the R combination of element is set of unordered selection of R element. R element is based on the set. Thus, R element is simply a subset of this set with the R element. Okay, for example, we have S 1, 2, 3, 4. 1, 3, 4 is a 3 combination of S. Okay, and then the R combination of n distinct element is denoted by C and R. C is combination. R combination is based on set. Okay, please remember for the R combination, okay, and R permutation, R is for the set. Okay, this one R combination is for set. So we have 4 and 2 since is equivalent to 6. Since for example 2 combination of set 1, 2, 3, 4, we list all the possibilities of set 1, 2, 3, 4. 1, 2, 3, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. So how we calculate the combination C and R? Consider the following obtain R permutation of set in the following way. So first we form all the R combination and then we generate all the possible ordering. Okay, so we have C permutation and R. This one for the combination. C and R multiplied by P, R and R. Okay, so we combine, we can have n divide by R exclamation mark and a factorial exclamation factorial and minus R. This one is for factorial. So to answer our initial question, how many ways are to pick a set of make sure this one you read carefully. A set is basically for the R combination. Okay, for the R combination, you have to choose the P and R and divide by P R R permutation n. Okay. So if you put this one, okay, you have 720 multiplied by 36 is 20. There are 20 different ways. That is 20 different group to be picked. And then we have corollary. Okay, this one is picking a group of R from a group of N. It's the same of splitting a group of N people into group of R. Okay, because this one is a combination, the ordering is not important. Okay, for the combination, we have C and minus R. This one for the corollary. Corollary. Okay, this one is basically for the symmetry. Symmetry, intuitively plausible. Okay, what is corollary in a discrete math? A true statement used to proving other true statement. A simple deduction from a theorem of proposition. Okay, and then this one, picking two element and leaving four is essentially the same as picking four and leaving two. This one is either way. Okay, permutation and combination. Soccer club has 8 female. Okay, please read carefully, and 7 male members. For today match, the coach want to have 6 male and 5 male players on the grass. How many possible configuration there? And then we have C86, C75, okay, 7, 8 male and 8 female and 7 male. And six coach want to have 6 male and 5 male. Okay, so we combine female and female, male and male. Okay, so we can have the combination of 8 factorial 6. Okay, this one is factorial n minus r. Okay, okay, multiply by 7. Okay, factorial divide by 5. Multiply by 2 factorial. Okay, so we have 588. Okay, we have n factorial n minus r. Okay, we have 8, 6. Okay. Okay, that why we have 2 and 7 minus R 5 R 2. Okay, so this one 2 so we got here 5. Okay. Okay, this one exercise. How many ways that are this one you do in the Padlet? How many ways there are to select 6 students from a class of 25 to serve a community? Okay, R is student and N is 25. Okay, for this one is you use the combination. Okay, okay. This one class of 20 sophomores and 15 freshmen. Then the club need to choose 4 different numbers of the to be the president, secretary, and treasurer. So we have permutation and permutation R. So we have 20 sophomore and 15 freshmen. This one you need to choose a president, vice president, and T. Okay, and then the club need to 4 different members. Okay, and treasurer. Okay, then this one is fisherman is for the secretary. S. Okay, so if you choose this one, uh, 20 N PR1 20 N is 20 sophomore P3 lah. Okay, P3 and then product role N2 PR2 we have 15 P1 lah. R2 is 1. Okay, okay because R1 is 3 we have 3 choices. Okay, and the fisherman only one choice secretary as a secretary. Okay. Okay, this one N1 T1 N1 T1 this one N2 T2 okay and then for the sum rule we go for the plus. Okay, for the product rule we go by the multiple. So this one is in order okay, in order uh, okay. Okay, this one is another exercise. We have 10 members. We have 4 letter anagrams. Okay, N is 6, R is 4. Okay, and then we have 6 and 4 here. Okay, this one, how many different words that you can form if you need to rearrange the letter. Okay, repeated element. Okay, 3, P3 lah. We have AIA. Uh, first AIA and then we have IAA and AAI 3. 3 uh, for the N and R is also 3 lah. We have 3 and then divide by P2. 3 3 divide by 2 and then we have 3. Also if you choose the permutation P N divide by N minus R. Okay. Okay, 0 factorial is equivalent to 1 lah. Okay. So we got 6 Okay, we got 6. Okay, and then this one assume that you have cooked 5 consistent male and female. Okay, and then you are asked to select a group of cooking consisting of 5 members. So, okay, we have 1 female, 4 male, 2 female, 3 male, 3 female, 2 male. Okay, and then we have 4 male, 1 male, and then we have 5 female. This one is the possibilities. Okay, we have 5 choices. Okay. Okay, so we have T1, T2, T3, and T4. Okay, 5, C1, 5, combination 4 plus, and so on. Okay, Okay, pigeonhole principle. I think we go by next week lah. I give you another example.